Hi everyone and welcome to tutorial 71 on understanding mathematical symbols. So these include things like equals, less than or equals to, less than, greater than or equals to, or doesn't equal. So in order to get started with this, what I first want us to think about is generally the equal sign. So here we have the equal sign and we use this when two values are exactly the same. Okay, so for example, we could write something like 5 equals 5. Okay, so we can see that on the board we have 5 equals 5, and that makes sense because if 5 is 5, 5 is 5. But one of the main things we want to know about in maths, and the kind of thing that actually allows us to take that leap later on with maths to the more complex stuff, is understanding that we can write 5 in a multitude of ways. So although I've got 5 equals 5 here, what I could also write is something like this, where I could put 4 plus 1 equals 2 plus 3. Okay, so these things still mean 5 equals 5, and that's that. So this is what the equal sign means. It just means whatever you have, the value on both sides is the same. So I could actually have something like 15 divided by 3 equals 20 divided by 4. Okay, so again, both of these sides still equal 5. What I really want you to get a grasp of is the fact that no matter what's going on, the equal sign just means that both sides are equal to the same, even though they might not look the same. And this is going to be really important when we start looking at algebra. Okay, right. I'm going to jump to the not equals sign now, okay? So the not equal sign is the one that looks like this, and we basically just use this when things aren't equal to each other. Okay, I know that sounds really obvious as well. So I could do something for this like 8 is not equal to 3. I mean, it seems like we're just pointing out the obvious here, but again, it's a useful sign. We often use it in maths. We could have something like, you might actually see it in an equation where they might tell you x is not equal to 0. Okay, that's a popular one that comes up because you might get a formula where you might have something like y equals 5 over x, and then they might say that x, where x is not equal to 0. And the reason they would say that in this scenario is because you can't actually divide something by 0. Okay, that doesn't work. So if you try to divide something by 0, it blows up, because essentially when we're dividing, we're sharing things between a number of people. So if you've got lots of stuff but no one to share it between, then that stuff just expands so much, and that's kind of what creates infinity. So yes, so x is not equal to 0 is a common thing that we're going to see, but also the not equal sign just means that two things are not equal to each other. Okay, let's have a look at another one. The next one we've got here is this sign here. Okay, now this sign means that whatever is on this side is smaller than whatever is on this side. Now, a way that I always was taught to remember it at school was that the crocodile goes after the big food, okay? So if you think about this being a crocodile, you're looking at the larger food. So if I had a 6 here, I'd have to have something smaller than that. So here I could have something like 2 is less than 6. And you know that the big one is where the crocodile is going. So the crocodile is after the big food. You can also think about it as this side is larger than this side. Okay, this is the small side of the thing, and this is the large side of the thing. So you can also think about it this way, but I feel like the crocodile is usually a bit more memorable. So what I'm going to do is I'm just going to quickly write down some things, and then we're going to put them in place. So let's say I had 3 and 2, 10 and 9, 4 and 5. First things first, the crocodile goes after the big food. What's bigger, 3 or 2? So I'm going to set my crocodiles going this way here. Yum, 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 yum. Don't put the crocodile lines on in your exam, because then they might get confused and it might not be right. Next one, 10 is greater than 9. So we are going to put the crocodile going after the 10. And 4 is less than 5. So the crocodile will go after the 5. Okay, right. let's have a look at some other symbols like this. So the other one you'll notice is when you've got it like this here. Now this is trying to combine our crocodile with the equal sign, okay? So this means, this sign here means greater than or equal to, or less than or equal to, depending on which way round it's going. So remember, the small thing will go here, and the large thing will go here. So if I had something written like this, I would say 3 is less than or equal to 6, or 6 is greater than or equal to 3. Okay, you can say that in both of those ways. Okay, you've just got to stop and think about it really. They are difficult because they just kind of get a bit confusing. But so here we've got 3 is less than or equal to 6, 6 is greater than or equal to 3. I could write something else like this. I could put the big number on this side here. I could say 10 is greater than or equal to 4, or 4 is less than or equal to 10. We can also have something like this. 5 is less than or equal to 5. Okay, right. What I'm going to do now is I'm going to go through some of the questions that we've got on the website. And these questions, if you want to find them, are on the site crackmaths.co.uk. And you're looking for tutorial 71 in the GCSE extra section. Okay, so let's have a look at the first one of these questions. So the question says, fill in the blank, and we've got here 8 blank 12. Okay, so 8 blank 12. Let's remember our symbols. Is it equal? Is it not? Well, there's a couple of things we could use actually. So we've got, is it equal? Is it not equal? Is it less than or greater than? Or is it less than or greater than or equal to? In fact, there's so many options that we could do here. So this is a misleading question actually, but it doesn't really matter because as long as we use a correct symbol for a question like this is going to be fine. So first of all, we could say 8 is not equal to 12. And we could also say that 8 is less than or equal to 12. Or we could also say 8 is less than 12. So we have 3 options there of things that we could do, and all of these things would be correct. Usually in these types of questions, they give you a collection of things to use. So depending on what you've been given to use, that will be helpful for you. Okay, so let's have a look at question 3. So this question says, complete the statement, 5 plus 2, blank, 9 minus 1. So what we kind of just do here is we have to think about what each of these sides mean. So 5 plus 2 I know is 7, 9 minus 1 is 8. So again, there's a collection of things that we could put in here. So we could have not equals, we could have 7 is less than 8, and we could also have 7 is less than or equal to 8. So all 3 of these things would be correct. Okay, let's now have a look at question 6, because I want to look at this because we've got a special word in here which actually covers the symbols that we're using. Well, actually, it covers the set of ones which are greater than or equal to. So question 6 says, write an inequality for a number x that is greater than or equal to 10. Okay, so we know we're looking for the greater than or equal sign. So I might actually just, well, I'm going to write x and 10 down first because that's kind of how we've been doing it. So I'll write x here and 10 here. Now, the word inequality refers to the less than or equal to, greater than or equal to, greater than or less than symbols. Okay, so let's see if we can put the correct one of those in place. So we want to put in x is greater than or equal to 10. Okay, so we have here, x is the greater thing, x is the big thing. So the crocodile goes after the big food. So I'm going to put this like this here. So here we have x is greater than or equal to 10. You'll notice on the site we've got a collection of practice questions and scenario questions. So now we've done a couple of those practice questions, I'm just going to jump over and do a couple of the scenario questions just to see if we can do this when they're in a bit more context. Okay, so question 4 says, the temperature in city A is -2 degrees Celsius and in city B it's 3 degrees. Write a mathematical statement to compare them. Okay, so as we've seen before, there's actually several ones that we could use, but I think what we need to do is think about which one is going to be the most useful. So I am first of all going to write down all 3, and then we can have a look and decide which one we think would be the best or most useful comparator for the two temperatures in this situation. So first of all, I'm going to write down -2 here and 3 here. So the first one I could have, which I'm going to kind of say is probably the least useful, but it's just to say that -2 is not equal to 3, okay? So we can write down to say that those two temperatures are different, okay? But that doesn't give us much information. Now let's see if we can get some more information than that. So we could also have -2 is less than or equal to 3, okay? So remember the crocodile's going after the big food. So here we go, we've got -2 is less than or equal to 3. Again, very useful, and it tells us a bit more information this time. But I think probably the most useful one in this situation is knowing that -2 is less than 3. So if you were like comparing the cities because you wanted to go on holiday and you're hoping for some hot climates, although maybe not when you're comparing -2 to 3 degrees, but if you wanted to know which one was warmer, this is probably the best statement. So we could actually say that City A has a lower temperature. Their temperature is less than City B. Okay, so what I want to do is I'm going to try 2 more questions from this because actually they take a little bit of an interesting dynamic here. So what I want to do is I'm going to have a look at question 7 first, and then I'm going to have a look at question 10. Okay, so here we have question 7, and question 7 says, a car must not exceed 70 miles per hour on a motorway. Write an inequality to show this rule. Okay, so we've got a number here, and we're talking about the speed. Okay, so we're going to write speed on one side, and I'm going to write 70 miles per hour on the other. Okay, now we've got to think here, the speed must not exceed 70 miles per hour. So that means that the speed can be anything like 60 miles an hour, 63 miles an hour, 62 miles an hour. So what we're looking at is we're looking at numbers that are lower than 70. So when we think about the crocodile going after the big food, that means that the speed has to be smaller than 70 miles per hour. So 70 miles per hour is the big food. So we've got here, the big food is over here. So the speed must not exceed. So it can go 70 miles per hour. So we're looking at this here. So we've got speed is less than or equal to 70 miles per hour. And remember, that's because the speed has to be these numbers which are smaller than 70 miles per hour. Okay, right, let's have a look at question 10 and then we're going to finish. Okay, so here we go. We've got question 10. And question 10 says, a bakery sells cupcakes for £2 each. John has £10. Write an inequality to describe how many cupcakes he can buy. Okay, right, this is interesting. So, essentially what we know is, first of all, we can probably write down that the number of cupcakes John can buy has to be less than or equal to £10, okay? So, I know this isn't the answer yet, but this is just our halfway house. So, the cost of the number of cupcakes that John buys has to be less than or equal to £10. Okay, so we know that the cupcakes cost £2 each. So what we kind of have to think about is how many cupcakes could we buy if he spends the whole of his £10. So what I'm going to do is I'm just going to write this out. So 1 cupcake equals £2. So how many cupcakes could he buy for £10? So I'm going to go up here. I'm going to write £10 down here. Now, I know that 2 times 5 equals 10. Now remember, you could work this out by doing 10 divided by 2, okay? And that would give you 5 as well. So it looks to me like if each cupcake costs £2, 5 lots of 2 is 10, that means we can buy 5 cupcakes. So we now know that this £10 is equal to 5 cupcakes. Okay, so we can now do a switcheroo with these, and I can put this 5 cupcakes in the place of this £10, and I will know that the number of cupcakes John can buy has to be less than or equal to 5 cupcakes. So let me write that down as my final inequality, and then that will be that. So, okay, and so what we get there is that the number of cupcakes has to be less than or equal to 5. Okay, and that concludes this session on using mathematical symbols. Remember, there is lots more practice available at crackmaths.co.uk, and this was tutorial 71, and it's the first tutorial in the GCSE's extra section. Okay, so long.